put this project together just over 2 years ago. With the northern part of this project here, which you can see in the blue outline, was the Stella project, which was owned by a private Australian company called Vista Minerals. And we merged that with a listed entity called Coventry Resources that had the southern part of the property. The reason we got particularly Vista Minerals involved in the northern part of the project is shown on this image, which is basically an image of the copper geochemistry and soil sampling. And you can see there's a very large copper anomaly. It's about 11 kilometres long and 6 kilometres wide, with a subordinate anomaly the other side of the main river. So the overall anomaly is about 15 kilometres by 6 or 7 kilometres. And that's at greater than 250 parts per million copper, which, as a geologist, that's a globally significant copper anomaly in one of the world's best porphyry copper belts. So other known deposits in this belt include Pebble in Alaska, which is 10 billion tonnes at 0.35 copper and 0.3 gold. It's the world's biggest undeveloped copper and gold mine. 108 million ounces of gold and 40 million tonnes of copper metal. And there are a string of other deposits in this belt through British Columbia and the Yukon, some of which are being mined, some of which are in the permitting phase. So it's part of a world-class belt in a world-class jurisdiction. That's the reason we've gone there. Now, we've got two main goals here. The first one is we have a small high-grade position here called Zackly. Zackly is a skarn deposit, and skarns are the types of deposit you see on the edge of the porphyry system. Zackly has a JORC inferred resource of 3.4 million tonnes at 1.2% copper and 2 grams gold, about 14 grams silver. Our goal is to triple the size of that to about 10 million tonnes. We believe 10 million tonnes at those grades is going to be economically viable, and I'll show you some of the cross sections and some of the work that we've done in the last 6 to 8 months that show where that resource growth is going to come from. Then the other thing we want to do is advance some of the porphyry targets, and these porphyry targets are much, much larger, potential to be hundreds of millions of tonnes to billions of tonnes in size, possibly at lower grades than the skarn itself, but certainly deposits that have the potential to be of global significance. So those are the two main goals. Just in terms of where we are, the project is about a 6-hour drive out of Anchorage. 90% of that drive is on good quality sealed road. So it's a relatively accessible project by Alaskan standards. We can do exploration for about 5 to 8 months of the year, depending on the season and exactly where we are on the project, but you can mine every day of the year. So there's a large alluvial gold mine about 20 miles from our project that operates 365 days a year. So mining isn't an issue. In terms of major infrastructure, there's a railway line, power line and main highway about 100 kilometres to the west of the project. So if a major scale project is developed, it will be easy to hook into that infrastructure for movement of concentrates, etc. Alaska itself, as a jurisdiction, is one of the best ones in the world. In the latest version of the Frazer Institute, I think Alaska ranked 5. So it ranked higher than pretty much every Australian jurisdiction except Western Australia. It ranked higher than most US jurisdictions. So it's certainly a place where you can do business. It's got a very pro-mining state government and a pro-mining governor. So it's certainly a place we can do business. And that's perhaps shown by the fact that Northern Star invested 260 million US cash there last year to buy the Pogo mine from Sumitomo. And subsequent to that, they've increased the resource size by about 30%. So it's certainly a place that's now on the Australian map. As I said before, the reason we've gone there is good geology and a good jurisdiction. This photograph just shows what the terrain is like. It is fairly rugged in places, other parts not so. Zackly, up to now, we have used helicopter support. This year and going forward, we'll be able to largely leave the helicopters behind. There is a drill road in there now that we've upgraded. And once we can cross one river, you can get pretty much unimpeded access to Zackly using 4-wheel drives. Mars, which is one of our porphyry targets across the other side of the valley there, you probably can't see in this light, but the photograph does show a very large alteration system there. So that's as a geologist, we get excited by that. Again, relatively easy to access. In that case, that would require helicopter support for the first round of drilling. If that was successful, that would justify then putting a road in. Getting a road permitted in Alaska is usually about a 6 to 8 week process. So it's something that we could get permitted during the off season and then have ready for the following drill season. I talked a little bit about the geology earlier, and I'm not going to spend much time on this. There's probably only 3 key points from this diagram. One is we're right on the boundary between the Tintina Gold Belt to the north. That hosts things like Pogo, Fort Knox and Donlin, so a number of world-class gold deposits. Most of our tenure is in the porphyry copper belt to the south, as I mentioned before, has a number of world-class deposits. There is a very strong northwest trending structure here, and where that intersects that terrain boundary, we see a cluster of intrusions which are associated with that large copper anomaly, and that's exactly the sort of syndrome you'd want to see looking for a new porphyry copper district. And the fact that you have Zackly there, that's the sort of empirical proof of the concept, because skarns form when fluids from a porphyry react with limestones, and that's exactly what we see in the field. And what we have here is we have about a 12-kilometre long, sort of almost east-west trending corridor that extends from Mars through Zackly to Saturn, and that's what I'll sort of spend most of the rest of the presentation talking about. So you can see here in this diagram, which brings together some of the information that we've collected in the last 12 months. The background image here is detailed magnetic data that we collected in September last year. You can see at the eastern end there, you've got a very prominent magnetic feature, which is our Saturn anomaly, and that's surrounded by a zone where there's no magnetite in the rocks. It should have been magnetite there, but it's been destroyed. And that tells us that that intrusion at Saturn has had fluids escape from it. They've reacted with the rocks around them, destroyed the magnetite, and in this case, migrated along a fault and then formed the mineralisation at Zackly. And that's giving us very strong circumstantial evidence that Saturn may be a porphyry. It's concealed by about 15 to 20 metres of glacial till, so it doesn't have a geochemical expression or an outcrop expression at surface, but it will be amenable to IP surveying. So that's part of the ongoing work for this year, is to do an IP survey there, generate drill targets, and we'll be drilling that later this year. Zackly in the middle, I've just shown on there the drill holes, the drill collars that we put in this year. This was originally discovered in the late 70s, drilled in the early 80s, and had very little work done since the early 90s, until PolarX drilled in 2017, converted the historic resource to JORC, and then we've done another season of drilling in 2018, which basically drilled underneath the resource and along strike to the east, and you can see some of the numbers that we've been coming up with there as we move further east. So this is outside of the JORC envelope. We've been getting sort of 15 metres at 2.2 grams gold and 2.3% copper, 9 metres at 2.3 gold, 3.3 copper, and then right out in the east, some really spectacular intersections between sort of 47 and 55 metres. That's almost true thickness of flat lying mineralisation averaging about 3 grams per tonne gold, pretty much at surface. I'll show you that in a cross section. That's important because that's where the growth in Zackly is going to occur. And then at the other end of the corridor, we've got Mars. Mars is a multi-element soil anomaly with supporting rock chip samples up to 7 grams gold and 7% copper at surface. The surface geochem anomaly is about 1.5 kilometres by 800 metres, and it sits directly above a magnetic anomaly and an IP anomaly. So basically, all of the porphyry exploration techniques are positive at Mars. Mars is just now effectively drill ready, and that's something we will drill later this year. This is Zackly. On the left-hand side here, you can see a black and red dashed line. That's the surface outcrop of the known resource. It's subvertical, averages about 5 metres true thickness, is likely to be mined from underground only, with a crown pillar in place so we don't have to mine the small oxide position there. It's dominated by high tenor copper sulfides, bornite and chalcocite, so we'd get a very nice concentrate from that. You can see the drill holes here. We've drilled underneath it this year. It will certainly extend at depth, and then we've drilled further to the east. And as we've moved to the east, I mentioned some of the results earlier, but the most important thing is that those holes right out in the far east the mineralisation's gone from being subvertical to subhorizontal. So we've gone across a fold closure, and that gives us a much greater potential for open pit style mineralisation in the eastern area. Just looking at just a couple of cross sections here. This one is just in the middle of the published resource, and you can see there the drilling that we did in 2018 has extended the resource envelope by at least 100 metres down dip on this particular section. As I said before, the mineralisation is generally quite coarse grained. There is coarse grained free milling gold present, so we're about to kick off a metallurgy program to evaluate how much of that gold we can get out through a gravity circuit, and then looking at flotation for a sulfide concentrate that hopefully will take the bulk of the residual gold with it. So that work will kick off in the next 3 or 4 weeks. Moving further east, this is quite an important cross section. You can see there on the left hand side of that cross section, our hole 21 still showing the subvertical mineralisation with some pretty good grades there. As we then move on to the right hand side of that cross section, you can see the mineralisation is now overturned. It's much thicker, and that's fairly typical in these sort of geological terrains where you have this type of folding, that one limb is often much thicker than the other one. In this case, potentially in a very nice open pittable position. That mineralisation goes right to surface. It's covered by about 2 metres of colluvium that's shed off the local hills, and that makes it more or less blind to geochemistry and certainly to mapping. But certainly something that's very easy to pick up with additional drilling. And it's something that we have picked up the fold trends in the detailed magnetic data. So we'll be using that detailed magnetic data to plan another 25 or 30 holes around this position, just to give you a feel for how this scale may sort of increase the position. If we drill similar grades and thicknesses, 200 metres in either direction along strike, and just add another 100 metres down dip, you're looking at something that's probably 6 million tonnes at 1/10 of an ounce a tonne. So that's 600,000 ounces in a position that could be open pittable at a strip ratio of around about 2 to 1. That's for a company of our size, that would represent something that we then think would be amenable to economic extraction, and that's something that we would then put into a feasibility study, ideally starting that in the 4th quarter this year, subject obviously to getting drilling results to give us, if not an inferred resource of that size, at least clear line of sight that we're going to get to that critical mass. Saturn now, moving from Zackly to Saturn, as we go from west to east in Zackly, we start seeing increasing grade, increasing thickness, increasing intensity of alteration. So it's all giving us a vector towards Saturn. And as I said, Saturn is a very nice magnetic anomaly in 2D. In 3D, it looks even more impressive. And this is just a snapshot from a little movie that I'll show you in a minute that shows that the Saturn porphyry position, you can clearly image there at least 3 kilometre deep, or 3 kilometres of vertical extent of an anomaly that's 2 kilometres by 1 kilometre at surface and extends down beyond 3 kilometres and is spatially associated with faults that go right through the Zackly skarn. So it fits the sort of the textbook of what you would expect a linked skarn and porphyry to look like. Now, if I can get this to work, I'm just going to show a very quick, it's about a 2-minute little movie here that just goes through why we think this is a good porphyry. These are just some examples of porphyry copper deposits around the world. This is what the type of target we're looking for. There's that large geochemical anomaly with the Zackly resource on the southern edge and that nice corridor. Again here, this is that 12 kilometre long corridor, Zackly in the middle. We're now going to move into 3D and just look at how that high resolution magnetic data has been imaged through what we call an inversion model. And we've just isolated the southeast corner there and worked that up. And you can see here we've got a series of flitch plans showing the magnetic data, and then this is the 3D isosurface of the magnetic part of that emerging. As I said before, it's about 3 kilometres in vertical extent, and that's only controlled by, that's how deep the model goes. This thing actually goes deeper than that. So it's certainly going down quite a long way, and then does link through to Zackly. We've done some similar modelling at Zackly, and what we found at Zackly is that mineralisation sits right on the steepest gradient between non-magnetic and magnetic rocks, and that's something that we can use to help us plan the drill targeting and the drill work for this year. So a very nice linked system, exactly what the textbooks should say we should be seeing. The work that's left to be done on that now is really to do some IP work on Saturn. You can see that's the thin blue lines there, which you can see in the handout. That's about a 20 line kilometres of IP work. It's about 2 weeks of work. We've got the contractor lined up to do that basically as soon as the snow lifts. And this particular area, that's taken out exactly, but the Saturn anomaly is much lower terrain, much lower relief, and something that's a lot easier to get onto. It's about 1,000 feet lower. It's on a south-facing slope, so the snow will melt there earlier than anywhere else. So we have a longer field season at Saturn than we do at Mars, for example. Whoops, let's go on. So yeah, that's sort of just the just sort of showing where that IP survey is going to happen over Saturn. Just a little bit on Mars. I'm not going to go through the detail here. Just some images that show the same area. On the left-hand side there, you've got the magnetic data showing interpreted intrusions, again surrounded by zones of magnetite destruction in some cases. And then on the right-hand side, that's the copper in soil anomalism. As I said, it's about 1,400 metres long, 800 metres across. We have a core of copper and molybdenum anomalism, and then it's surrounded by a bigger zone, which is about 2,000 metres by 1,200 metres of gold and arsenic. And that's the classic zonation you see around porphyry and epithermal systems. You can see here that anomaly is pretty much superimposed on the top of one of those magnetic anomalies. Just zooming in a little bit, these are just rock chip numbers on both copper on the left-hand side and gold in the right-hand side. So we have at the surface here, we've got altered rocks, we've got little fault zones and breccia zones that are going, you know, between sort of 0.1 and 7 grams gold, and the same with copper, 0.1 to 7% copper. We're not suggesting that's necessarily the grades of what we'll find underneath. It just shows that there's copper and gold in that system. So we have a magnetic anomaly, we have an IP anomaly. That IP anomaly sits directly below the peak of the geochemical anomaly. And as you can see from the photograph on the right-hand side, there's plenty of copper there in those Zara hills. That particular sample went over 50% copper. So we know it's a live system. What we don't know is how deep we've got to drill to the mineralisation, although the IP anomaly is suggesting 100 to 150 metres, and we've clearly got no idea what grade we're going to hit when we get down there. But the fact we're getting good grades at surface is certainly very encouraging. So that's sort of it technically. In terms of the work program going forward, as I said, we've just released the 3D inversion modelling that was released yesterday to the market. We're about to kick off the MET program. That'll start hopefully in the next 2 or 3 weeks, with some first results on the gravity stuff coming through in April and May. We've pretty much already finalised the ground geophysics program. That will commence in May at Saturn. So Saturn will be drill ready sometime in June, and we'll be in a position to drill test Zackly pretty much mid-May onwards, once the snow lifts. So all things going well this year, we plan to complete the MET program, do the IP survey, and drill about 6,000 metres. That would cover the expansion of Zackly, about 3,000 metres there, and then about 1,500 metres each at the Saturn and Mars porphyry targets. And then, subject to results, if Zackly stacks up and looks like it's going to hit that 10 million tonnes, and the metallurgy looks encouraging, then we'll commence some form of formal feasibility study on that in the last half or last quarter of this year, and that will help us then have continuous news flow throughout the northern winter. So that's pretty much it. It's we've got a large land holding package there. They're all state mining claims, so very easy to permit. We're in a tier 1 jurisdiction with tier 1 geology, and that's fairly rare these days, particularly given how underexplored Alaska is compared with other tier 1 jurisdictions such as Western Australia, where there's been 100+ years of exploration. Alaska's certainly missed out on that for most of its history. So we've got Relatively low hanging fruit at Zackly. We think that could underwrite the valuation of the company. So shareholders investing at 6 or 7 cents aren't going to lose their skin. But you've got that massive upside from the porphyries. And certainly the scale of the systems there looks very, very encouraging at this early stage.